Okay, so the other video, we just did 43. Number 46, I want to do with you guys as well, just because number 46 requires you to do some stuff you ain't done in a while. So we're still on page 339, and we're going to be looking at specifically question number 46. So I'm going to solve this whole thing. Question number 46 says a sample of silver chromate has a mass of 25.8 grams. 25.8 gram sample of silver chromate. All right. Now, part A says, write the formula for silver chromate. So that's what we're going to do real fast. So you see silver here is Ag. Now, a little bit of a hairy thing here. See, silver is a transition metal, but it's one of the few transition metals with only one naturally occurring charge. So if it's not specified with Roman numerals, it's going to be a +1. And I'm not going to make you guys memorize things like that on tests or whatnot. I'll give you the Roman numeral. But just because there's a handful of your transition metals like this, not very many, but some of them, and I just never had you guys memorize those. But I figured you probably Googled this anyways, because you could just Google the name and it tells you the formula. Don't do that on a test, because if you get caught doing that, it's cheating, and you'll get a 0. But, you know, either way. Now, the formula for chromate, you guys should be able to look up. See, chromate is a polyatomic ion, and it's on your polyatomic ion sheet on the back of your periodic tables. So chromate has a charge of -2. And to write an ionic formula, you take your charges and you drop and swap them. So it's kind of like a crisscross down here, which is another way you've heard this from somebody, Miss Moore, if you had her for physical science. But remember, you do this because you're balancing charges. But this is a nice shortcut. So you got silver, you need 2 of those, and you've got chromate, and you only need 1 of those. So Ag2CrO4 is your formula. Now, part B to this question wants to know how many cations are present in the sample. So part B, 1 Ag2CrO4 has 2 Ag pluses. Notice this relationship is actually very similar to what you had to think through in question 43. It's just phrased differently in the question. Part C wants to know how many anions you have. Well, for every one of these boys, you've got 1 CrO4, -2. Now, you see, I'm not writing any units here for either one of these numbers because technically there's a couple of possible units. I could compare 1 molecule of this guy, and of course I'd be looking at ions over here. But you could also think about this as the mole ratios represented. For every 1 mole of these guys, I'd end up with this number of moles of these guys because it would be a grouping of the ions. So that's why we call these little numbers down here the mole ratios, because mole is a measurable amount, whereas a molecule and an ion, you're never going to be able to isolate one of them. Like, it's just not going to be feasible. But either way, these are the answers they're looking for. They're 2 and 1 for B and C. D wants to know how many grams of 1 formula unit of silver chromate. So, what is the mass? Oh, I misread the question. I misread the question badly, and I just realized it. The questions for B and C weren't asking how many ions were in one of these. It was asking how many ions were in 25.8 grams of silver chromate. So I actually got some math to do for B and C. Whoops. So we got 25.8 grams of Ag2CrO4. We need to convert these grams of Ag2CrO4 to moles of Ag2CrO4. And then we got a choice here. A choice because of what I mentioned right here. So there's a couple ways to do it from this point. The way I'm going to do it is I'm going to continue on and say, I need to know how many formula units I got. So for every 1 mole of Ag2CrO4, I have 6.02 times 10 to the 23rd formula units. I'm going to figure out what this answer is, because this is basically the same thing I did up here. So, slide this up a bit. I don't need that top portion anymore. 25.8 divided, oh, look at me, getting ahead of myself. I divide by the molar mass. I haven't figured it out yet. So what number goes there? Well, for the molar mass, I have 2 silvers. So 2 multiplied by the molar mass of silver, which is 107.87. To that, I need to add the mass of 1 chromium. Chromium has the mass of 52 grams per mole. And I need to add the mass of 4 oxygens. Each oxygen has a mass of 16, so I have to add all of that mass together to find my molar mass. 2 times 107.87 plus 52 plus 4 times 16. The molar mass I'm looking for, 331.74 grams of this bad boy. My bad. So 25.8 divided by 331.74 multiplied by Avogadro's number, 6.02 times 10 to the 23rd. So my answer here that I've got so far is, I'm just going to write this right here, 4.68 times 10 to the 22nd formula units of Ag2CrO4. The question in part B is asking how many cations are present. That's where these relationships are going to come in. For every 1 formula unit of my molecule here, Ag2CrO4, I have 2 ions of Ag. And then to answer part C, since I've already basically done everything else needed, I have the same number of formula units of Ag2CrO4. And all I've got to do for every one of those, I have 1 ion of chromate. And so I've just got to take this number and multiply it by 2. Gives me this number, 9.36 times 10 to the 22nd ions of silver. And of course, multiplying and dividing by 1, 4.68 times 10 to the 22nd ions of chromate.
Brianna?
So,
Welcome to the 21st century. How did we come to be here?
Bam. B and C are solved. I misread the question. That's my bad. Now question D, though. Question D is one of the reasons I wanted to do this problem with you guys, because this is exactly the same as 43 was. Part D is where life gets pretty interesting. Part D says, what is the mass in grams of 1 formula unit of silver chromate? It's unrelated to the rest of the question. So what it wants to do is you have 1 formula unit of Ag2CrO4. And you're going to convert formula units all the way to grams. So you're going from your particle, and you're going to convert to moles, and then we're going to convert to grams. Question D gave us a new number of particles, only 1. This is the number of particles in 25.8 grams, so our answer is going to be much, much, much smaller than that number, right? Because we only got 1 particle now. So to do this, I already know there's going to be 2 steps. I need to cancel the units of formula units. So I have to use Avogadro's number of formula units for every 1 mole. Now I've got to cancel the units of moles because I'm looking for mass in grams. So for every 1 mole, I have to use my molar mass here. 331.74 grams. So 4 milliunits are canceled out, moles are canceled out, and I'm left with the units of grams. So all I gotta do is type this into my calculator, and I'm done. 1 divided by Avogadro's number, multiplied by the molar mass of silver chromate, 331.74, and that's it. And if you notice, I do get a very, very small number, 5.5 times 10 to the negative 22nd grams silver chromate. Now, some of you guys get uncomfortable writing and doing math with numbers in scientific notation. This number is just a number. This exponent is just an exponent. What this means is that negative 22nd there means that this decimal moves 22 times to the left. So if I was to express this as a real number, it would literally be, I have to count here, 22 times so that's 21 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 5 grams. That is how small that number is. It's just a number, but it's tiny. That's the mass of these atoms combined together in this way. One of them has this mass. So when you see stuff in scientific notation, it's perfectly fine. It's just a number, just really big if it's a positive exponent, or really small if it's a negative exponent. So, in this video here, that is question number 46.